Let me first introduce our first speaker. Dr. Martin Mills lectures on anthropology and Tibetan history and culture at University of Aberdeen in Scotland. He is the director of Scottish Centre for Himalayan Research. He is the secretary of Scottish Parliament Cross-Party Group on Tibet. In 2020, the Scottish Parliament Cross-Party Group on Tibet initiated the Third Pole Climate Inquiry and commissioned the Scottish Centre for Himalayan Research to look into the causes and impacts of climate change in Tibet and wider Third Pole region. The SCHR has recently produced a 38-page research report on climate change on the Third Pole, its causes and consequences. So Dr. Martinla will speak on this topic. Over to you, Martinla.
Thank you. Yes, just a quick reintroduction there. My name is Martin Mills. I am the director of the Scottish Centre for Himalayan Research. The Scottish Centre for Himalayan Research has worked for the last 10 to 15 years in cooperation with the Scottish Parliament's cross-party group on Tibet. Our job is to provide advice. I'm not an activist, I'm not a politician, I'm an academic, I'm a scientist, and much of what you're about to hear is about academic stuff and science, and I make my apologies for that, but I really shouldn't. Over the last 10 years in particular, the cross-party group on Tibet has realized that an increasing number of the issues related to Tibet circle around the question of climate change. And in 2019, we began by, we initiated a climate change inquiry to, basically speaking, review in particular the scientific data that related to climate change on the Tibetan Plateau and the wider Third Pole region. The purpose of this was not to look at politics or activism or anything on those lines, but to simply review, in effect, the science. As part of that inquiry, we reviewed over 900 scientific publications that were centered on this area. These came from a wide variety of organizations in Nepal, India, America, the Chinese Academy of Sciences. We took scientific data from wherever appeared to provide reliable scientific data on this matter. We were seeking, moreover, the particular consensus of scientists across the disciplines. So what you see here, is, effectively speaking, is a summation of that in largely qualitative terms. You will be pleased to know there is no mathematics in this. Okay, moving on. The Third Pole. Why do we use this word? The Third Pole is a region surrounding and including the Tibetan Plateau. It is a region, roughly speaking, the size of Western Europe. The Tibetan Plateau itself is a million square miles, so it's fairly large. It's at 4,000 meters, which makes it one of the largest geological features on Earth. And the reason why we call it the Third Pole is because outside the Arctic and the Antarctic, it is the largest supply of frozen fresh water on Earth. Its cryosphere is a word that we use, and I will use that word several times. Cryosphere, effectively speaking, means its domain of ice. Rather interestingly, it actually corresponds pretty correctly to the oldest known Tibetan language term for Tibet, which is Kawachen, or the land, the abode of ice. And more to the point, unlike the other two poles, it is the only pole on Earth that is surrounded by half the world's population on its doorstep. And that makes the most vital difference. Now, to understand the cryosphere, let me move very, very quickly. This is going to be ABC for some of you, but I'm sure it may be new for a few of you. The Tibetan cryosphere, its domain of ice, involves three components. Okay? The first, rather obviously, is snow. The second, rather obviously, are its glaciers. The third is a kind of unseen component, and that is its permafrost. Okay? That is those sections underneath the ground that are permanently frozen for more than 2 years at a time. And in many cases, in the case of the Tibetan Plateau, in areas such as Siberia and so forth, the permafrost is thousands and tens of thousands of years old. Just in case you didn't know, permafrost actually covers 25% of the land mass of Earth. So it is a major feature on Earth, but we don't see it because it's usually about 1 to 2 meters underneath the ground. You can actually see that in the slide there. I'll come back to that one. Combined, the glaciers, snow, and ice and permafrost of the Tibetan Plateau, its cryosphere, constitute the most fundamental regulating mechanism for the water cycle in Asia. So let me skip very quickly to the conclusion of our paper. Global warming, global climate warming, amongst other factors, but first and foremost amongst those factors, global climate warming is causing a catastrophic collapse of the third pole cryosphere and its capacity to regulate water all across Asia. That will have, over the next century, catastrophic consequences, not simply for Tibetans, but for, effectively speaking, Asia's larger capacity to support agriculture, industry, and human populations. Now, I know that is a very serious assertion, but let me be very clear. That process is entirely underway now. And to all intents and purposes, there is no plan to stop that. So, let me explain what that means in more precise details. Apologies now, very quick geography lesson that you will remember from your secondary school. Water cycles. Water cycles are what allows the human race to live. We all live inside a water cycle. Everywhere on Earth that there is a human population, it exists within a water cycle that does, basically speaking, two things. The first is it turns salt water from the seas into clouds. Secondly, those clouds turn into rain and flow into rivers from which we get our fresh water. Fresh water constitutes 2.5% of the world's water supplies. We can't use salt water for industry, we can't use it for agriculture, and we can't drink it. The fresh water supplies is all we've got. That constitutes, as I say, 2.5% of the Earth's supply of water, most of which, I hasten to add, is locked up in the poles, which are away from human populations and land masses. So actually, it's a tiny section of the water supply of Earth is available to us. One of the most major sources for regulating that is the third pole. Now, how that works, effectively speaking, in the third pole context is that the Tibetan Plateau is cold. Or at least it has previously been cold, and it accumulates ice. So what happens, as you can see from the slide, is during the rainy seasons of the year, the heat causes water to evaporate and turn, effectively speaking, into evaporated fresh water that goes in the clouds. They find their way towards the mountain zones at the center of Tibet, at the center of Asia, which is the third pole. There they fall as either rain or snow. When they fall in particular as rain or snow in a cold region, that turns to ice. Now, that's an important component. Effectively speaking, it's our fridge. It stores that fresh water as frozen fresh water in glaciers, in permafrost, and in snow. As a consequence, the amount of water that pours down upon the Himalayas, quite a large slab of it every year, is saved up during the rainy season and held back on the third pole. Meanwhile, the rivers, for the rest, flow down across Asia, across China, across Pakistan, across Bangladesh, across Southeast Asia, across Central Asia. They flow down and they provide us with the capacity for agriculture, for industry, and for keeping our cities and populations going. Okay? During the dry season, however, that fridge provides us with ongoing water. Effectively speaking, it slows down the flow of the water cycle such that during the season where there is no rain, there are still rivers that come from the meltwaters from the Tibetan Plateau region. Okay? So the Tibetan Plateau region, by being colder, actually allows those rivers, that is the key kind of 10 major rivers of Asia, the Indus, the Brahmaputra, the Mekong, the Yellow, the Yangtze, the Tarim, all of these core major rivers in Asia flow all year round because of the Tibetan cryosphere. Okay? So in that sense, it serves to regulate that process. And in regulating it, it's provides crucial year-round support for human populations in all of the major river basin areas around Asia. So if we look at the green area there at the center, that's what is often referred to as the Hindu Kush Himalaya, or the Tibetan Plateau, or third pole. It's the high altitude regions from which you can see all of those rivers flowing. The blue-purple areas are the river basins that are fed by those rivers or that feed into those rivers. Now, just to give you a sense of the numbers of people that we're talking about, if we look at the third pole region itself, that is a population of 225 million people. If we look at those that live within and depend upon the constancy of those rivers that come out of the third pole region, we are looking at 1.9 billion people that depend upon those rivers to survive year-round. If we are thinking about the population on Earth that depend upon the products that emerge from that agriculture and industry of that area, we're really looking at about 4.1 billion people. So we're really looking at half the world's population depend upon the Tibetan Plateau and the Tibetan cryosphere to remain consistent and solid as a regulator of those rivers. Now, the problem with it is that that function is seriously compromised right now and looks like it will collapse almost entirely within the next 50 years. So, I'm hoping we can just make this go forward. There we are. Let's ask the first question. Why is it changing? Okay, there are three major reasons. There are actually hundreds of reasons that are causing this transformation. In order of actual impact and importance, the single most important effect here is climate change itself and global greenhouse warming. All right, that is an effect in magnitudes larger than everything else. Okay, the second, effectively speaking, is South Asian air pollution. Okay, the way the winds flow across the Tibetan Plateau is largely from the west, and they draw air up from Asia, across the Himalayas, across the Tibetan Plateau, and from there the winds tend to pass towards sort of northern China and places on those lines. So northern China, for example, often receives sandstorms from the Tibetan Plateau. The third of these is deforestation and urbanization. These affect water flow. Deforestation affects water flow because forests slow down water movement. Their roots, their leaves, all of these things act as a filter and a slower of those processes of water transfer. Deforestation also obviously has effects in terms of climate change and in terms of greenhouse warming. Urbanization tends to be a more localized effect. It has a warming effect. I came down from Aberdeen yesterday. As we come into London, everything becomes markedly warmer. Cities warm their surrounding areas, and they melt glaciers and they melt permafrost. They do that thing. Now, across the Tibetan Plateau, we have seen, in the course in particular of my lifetime and the lifetime of everybody in this room, a marked uptick in general temperature. There's a chart, okay? There are a couple of features of this chart that I'd like to draw attention to. Most substantially, the most substantial shift is really from about the mid-1980s onwards. You can see on the sort of right-hand side of the diagram that significant shift. I first went to Lhasa in 1986, and my last time there was actually 2004. But if you speak to anybody who's on the Tibetan Plateau, they report a consistent process of dramatic warming. Okay? If you were there in 1986, you had to wear padded clothes all the time. These days, people are wandering around Lhasa in Bahama shorts. That's the difference that we're talking about there. It is a signal difference. Now, let me make something else clear about this, and that is the line that goes along the middle of that diagram. That is 0 degrees centigrade. That is the point where ice turns to water. It is a threshold. And if you go above it, all ice turns to water. Okay, so this is an important point. This is not about how much global warming there is. It is about whether or not you have stepped over that threshold. And to all intents and purposes, the Tibetan Plateau, as a general layer of temperature, has stepped over that threshold within the last 40 years. Okay, and that causes a dramatic increase in the speed at which these events occur. If we're looking forward, if we continue projections for that time, the Tibetan Plateau is expected to heat up, roughly speaking, on an average temperature if we continue with business as usual as things presently stand, my apologies for the slightly technical diagram, business as usual is what is referred to by the United Nations as RCP, Representative Carbon Pathway 8.5. All right, that is basically, we keep going where we're going, all right, and we don't do anything to change it. We would be looking at a temperature change across the Tibetan Plateau of about, at maximum, 5 to 6 degrees centigrade. That would be a catastrophic loss of the entire plateau's cryosphere, and therefore its capacity to regulate water. 4.5 is a significant reduction in our present capacities for producing carbon dioxide and adding to the presence, to the present amount in the atmosphere. The Paris Agreement, by the way, just in case, some good news in all of this, is about RCP 1.9. That would still involve a 2 degrees temperature rise across the Tibetan Plateau. I would say, however, by the way, as far as this is concerned, the temperature rise is asymmetrical, it's not uniform. What the real cause of the temperature rise, the form of the temperature rise on the Tibetan Plateau, is the loss of cold days. The loss of freezing days in particular. The summers aren't actually getting dramatically warmer, but the winters are. Now, a lot of that occurs because you are at altitude. The Tibetan Plateau warms at 2 to 4 times the speed of sea level. This is called altitude-dependent warming. It's caused by the fact that the higher up you go in the troposphere, the more global warming occurs. There are also effects caused by mountains. Now, what does that mean, all of that, for the third pole region, for the Tibetan Plateau, for the Himalayas, for the Karakorams, for the Kunlun Mountains, for the Tian Shan in the Uyghur regions, for all of those areas? What does it mean? Okay, well, most obviously, it means the loss of glaciers. Since 1970, roughly speaking, we have seen a 15 to 30% loss in glacial mass across the third pole region. It varies slightly. The further you go west, the less you lose glaciers. The reason for that is those winds that come in from the west, they tend to actually maintain the temperature, and there's something about rock cover. But across the borders, we have lost already, particularly in the Himalayan regions, roughly speaking, about 30%. That process of loss has accelerated in the last 20 years. To the extent to which we can, effectively speaking, there is consensus in the scientific community that across the third pole, the majority of glaciers will be lost by the end of this century. That is excluding the possibility of what we refer to as positive feedback mechanisms. There are quite a few in place, but we can't quite calculate how much of an effect they have. Effectively speaking, that would increase the speed of melting. It is important to note, let me be really clear about this one, that melting process does not require the temperature to get any higher to continue. Put it in most of our everyday experience, we put the ice cube out in the sun, all that is required is time. Glaciers happen to be much larger than ice cubes, they melt slower, but they do melt. The second component is permafrost. The impact on permafrost, let me explain quickly permafrost to you, and I appreciate, I may run slightly over time here, but let me explain permafrost to you. Permafrost is ordinary frozen ground if it's 2 or 3 years. If that timescale of low temperatures continues for decades and centuries and millennia, the ground separates out such that you get quite literally an underground iceberg. The depth of permafrost on the Tibetan Plateau is something that we are still working on. We don't know the precise depths, but this can be very, very deep. That underground iceberg in certain sections of Siberia, for example, is as deep as 1.5 kilometers. In certain sections of Canada, 740 meters is the deepest depth. So that is a substantial section of the landscape. Above it is a little bit called the active layer, and that active layer you can grow crops in as long as it's deep enough and as long as there's water. And thankfully, one of the great advantages of permafrost, of ice, is that it is waterproof. Therefore, water that falls as rain upon permafrost tends to stay quite close to the surface. So you can have grasslands and you can grow barley, as people do on the Tibetan Plateau. The permafrost structure on the Tibetan Plateau has undergone a systematic fragmentation over the course of the last 60 years. I'm going to this, roughly speaking, is a mapping of permafrost across the Tibetan Plateau in the 1960s. The blue area there is deep permafrost. The areas in red and yellow are warm and basically thawing. The areas in white are areas where there is no permafrost. So that is the 1960s. This is the 2000s. So, and that, I hasten to add, is the early 2000s. We are already 20 years after that. Much of that permafrost has simply disappeared. So much of that function of the cryosphere has gone. What happens when permafrost goes? Well, there are some local effects. So let's talk about this in the Tibetan context. We've seen those local effects in Siberia. We're seeing them in Canada. Basically speaking, what happens when you melt the ground? It collapses. Roads collapse, railways buckle, oil pipelines crack and explode, gas pipelines do the same, buildings fall apart, and effectively speaking, infrastructure across the board begins to fail. Okay, this is happening in large cities across Siberia at the moment, and we are beginning to see that. I'm afraid to say I've missed a slide here, but I will explain it to you. One of the major problems for the Tibetan region is that permafrost holds together much of the surface of most mountains in the third pole region. The flanks of Everest, Kanchenjunga, K2, all of these are permafrost, and permafrost acts like glue to hold them together. When it melts, that glue fractures. Now, we have actually seen this across the Tibetan Plateau and many of you will have seen, for example, the glacial collapse that occurred in Uttarakhand at Chamoli back in February, for example. It made the international news. A very large slab of a mountain basically fell off. It was a combination of both snow, ice, and permafrost, large quantities of ground. It hit nearby surfaces. I mean, I'm quoting here actually, with the energy output of 15 atomic bombs. The flow that came from that walked through the two nearby hydro dams as though they were made of matchstick. They literally lasted between 2 and 6 seconds before they were fatally compromised. The water turbulence from that made drinking water from that single event, made drinking water in major cities downstream of it non-viable for the next 2 weeks. And water turbulence was found from that collapse 900 kilometers away 2.5 weeks later. That gives you some sense of the forces of nature that are released by global warming. They are not simply, it's not simply, we're not getting back what we put in. We're getting back, in terms of consequences, 10, 15, 100 times more energy release than we are putting in. And that's an important component of climate change. Obviously, from the Tibetan perspective, this means whole communities are in danger. There is, many of them are in valley areas that are at the bottom of steep slopes. The Yarlung-Tsangpo River, the major river that crosses across the Tibetan Plateau in the southern region, has blocked from landslides. These are often caused by something else. So, for example, an earthquake, which 40 years ago would not have caused a landslide, can now cause a landslide because the land is so much more unstable because of the warming. If we run through, for example, landslides that have blocked the Yarlung-Tsangpo, that is the river that feeds into the Brahmaputra and feeds much of eastern India, the first recorded blockage of that was in 1953, the next one was in 1968, the next one was in 2017, the one after that was in 2017, the one after that was in 2017, the 7 after that were in 2018. That is the speed at which this is accelerating once you go past the threshold. We know also, for example, just as a side point, that the railway between Golmud and Lhasa is expected by Chinese Academy of Science engineers to be effectively almost completely compromised within 15 years. It is suffering from slumpage. It goes across about 1,000 kilometers of permafrost, and the railway underneath it, while incredibly well designed to stop heat moving from the train, cannot stop the landscape around it changing. And there is very strong view that, basically speaking, that railway, which with all the infrastructure that it provides, is increasingly compromised. Now, the last bit is this. What happens when permafrost melts? Well, here's a picture. Here's a diagram. As we saw, this is what permafrost looked like. The light brown area is permafrost underneath the ground in a mountainous area. When precipitation lands on, say, a glacier or on a nearby area, it lands in snow or rain or something on those lines, it soaks into the ground until it reaches the permafrost. At which point, because ice is waterproof, it stops. So it stays quite close to the surface, and water pools, and it moves around just underneath the ground. This allows grasslands to grow, it allows you to grow barley, it allows you to grow all of these things. Yaks can flourish, goats can flourish. You can have an economy on that. What happens, however, when the permafrost melts is simple gravity. Effectively speaking, the water falls into the area underneath the frozen land. Now, that area has actually been shielded from water for tens of thousands of years. So it's very dry, and it soaks it up. Unfortunately, as a consequence, the water table falls. It falls beyond the roots of grass, beyond the roots of barley, beyond the roots of trees. So it falls into the deep earth. And this has caused a pattern. There are other causes to this, but this appears to be the consensus on, particularly in the Chinese Academy of Sciences, who's been doing a lot of work in this area, and the IPCC scientists, that effectively speaking, this process is causing flash desertification to spread across the Tibetan Plateau, particularly in river headland areas, but actually in a wide variety of areas. This is turning to this. Now, originally that was blamed on the nomadic pastoralists, that it was their bad land use and everything else. I hasten to add the Chinese were simply taking a page out of any development book they could have found from the 1980s at that point. But what appears to be going on, particularly in these high altitude areas, is a much deeper process of structural collapse of the cryosphere. Now, we can tell that that structural collapse has occurred from, from recent NASA satellite output. There's something called the GRACE and GRACE-FO satellite programs. Basically speaking, their purpose is to measure gravity around the Earth. You have two little satellites. They spin round. They're about 220 kilometers away from one another. And as one moves into a heavier gravitational well, it speeds up. so the distance between them changes, so you know you've moved into an extra gravity well. What produces extra gravity? Well, ice produces extra gravity, water produces extra gravity, mountains produce extra gravity. The GRACE FO satellites have shown that the Tibetan Plateau's basic mass is changing. Okay. In particular here, this is a very simplified map, but it will help. The areas outside the third pole, so basically speaking, the Nepalese footlands, areas like the Punjab, Kashmir, places on those lines, are losing underground water. By contrast, the area inside those mountains, if you imagine the mountains as like a goblet, and you're just allowing all of the goblet, the water to flow to the bottom, the Tibetan Plateau within the mountain ranges is increasing by between 7 and 10 gigatons per year. Whereas the areas outside it, water is flowing away. Okay, so we know that a major ecosystem shift is occurring. The satellite data finally confirms that. And that will profoundly affect what is called the hydrology, the movement of water from the Tibetan Plateau. Okay, very, very quickly, just to finish up, what does this mean let's click to, what does this mean for Asia, actually, since I need to speed up. What that means for Asia is very simple. If you lose the regulating capacity of Tibet's cryosphere, then you lose regular water supply across Asia. Effectively speaking, there are some areas where that's very straightforward. You lose your glaciers and you lose all of your water. There are some rivers like the Tarim River, for example, in Xinjiang, they're almost entirely glacially fed. Once the glaciers are gone, that's it. But much of Asia, such as, for example, southern China or India and Nepal, are actually fed by rainfall that comes from the Indian Ocean. Okay? Now, when that usually arrives, what would previously happen under a non-warmed environment was that a lot of that water would be captured on the Tibetan Plateau and the Himalayan regions. Therefore, what comes back across India and across southern China and so forth is a regulated amount of water. What you will now get is huge quantities of water that will bring very large quantities of mountain down with them for the next 50 years. And we've seen that certainly in the number of mass flood and flash flood events that have increased and cycled rapidly across the southern Himalayan regions. The greater problem from our human perspective, however, comes with the other side of this, that water disappears down to the sea and then it is effectively gone. So in the dry season, you have no trickle down from the glaciers, from the permafrost, from the snow, because you don't have those things anymore. That, effectively speaking, means that many of the major Asian rivers could become simply seasonal. And a seasonal river cannot support a human population year-round. It certainly can't support large urban conurbations. It can't support industry, and it can't support, most particularly, the first growing season of the year. So, for example, large slabs of northern China, the Punjab, much of northern India will face an increasing process whereby those rivers will simply dry up. We know this is already happening with rivers such as the Indus. Areas around the Indus, cities like Leh, for example, people are simply moving away. They're moving, more to the point, they're spotting this is happening in a slow process, and they're sending their kids away to places like Jammu to study so that they will not be in an area where there is no water. We're seeing an intergenerational movement of population. So, when that happens, desertification increases across the board. Now, desertification has been a massive problem for northern China for decades. The Chinese themselves have thrown huge quantities of money at this problem, the South-North Water Transfer Project, things on those lines, but it is really something they can't hold at bay. Once the Tibetan cryosphere undergoes systemic collapse, which to all intents and purposes is in the process of now, that process of desertification will accelerate. So, if you wish to read more and look at more in-depth study of this, the report from the Scottish Parliament's cross-party group and the Scottish Centre for Himalayan Research is publicly available at that website, www.scotlandtibet.wordpress.com/reports, where you can download a PDF at your leisure. Thank you.
Thank you very much, Martin La, for your wonderful presentation and your in-depth analysis on the topic.